So the idea now is to talk about fast exponentiation in cryptography. It's used in cryptography, but it's a general method. So let's see an example. If I have this value, I want to take the x to the power of 26 and I want to see how to do that. What I can do is to look at the exponentiation in binary. So how would you write 26 in binary? It's 1 1 0 1 0 base of 2, right? Maybe I'll do it bigger so you can see it very clearly. 1 1 0 1 0 on the base of 2. Now I will use this representation to make a method to do the exponentiation in more efficient way. Instead of just calculating x to the power of 26, which is x, I'm going to do a more efficient way. How would I do that? The idea is like this. I will do x times x, namely I'm making a squaring. This is x to the power of 2. Now I'm going to take x times x squared, it's x to the power 3. Now x to the power of 3 times x to the power of 3 is x to the power of 6. Just for you to remember, alpha power of a, all of this power of b is alpha of a times b. So remember this. So this is x to the power 3 squared, which is x to the power 3 times 2, which is x to the power of 6. Okay, so it should be clear. Now let's continue. The next one will be x to the power of 6, and I will explain why I do exactly this. And the next one will be x times x to the power 12, it's x to the power of 13. And the next one is x to the power of 13 times x to the power of 13, which is x to the power of 26, and this is what I wanted to get to. Now I started with squaring, and then I did multiplying by x, and then I did squaring of the number by itself, and then again squaring, and then I multiplied, and then I again squared the number by itself. Now, how did I know when I should square or when I multiply? The idea lies on this number using the binary representation of the exponentiation. What is the idea? The idea is this one. If I look on the binary representation, I start with x to the power of 1, right? This is x to the power of 1. Now, what I want to do is taking the square of this. What will happen? It will be x to the power of 1 and then 0 to the base of 2. Remember, when I have a binary number like 1 1 0 1, and I multiply this by 2, it's just like making a left shift and adding a 0. So this will become 1 1 0 1 and 0 in the right. This is very important. Remember this. Now this is exactly what I'm doing. I want to create the exponentiation in the binary form. So if I start with x to the power of 1, what I should do, that create this one, to make it x to the power of 1 0, and then add 1, and then 1 1 add 0, and then add 0 and add 1, because to add 1 I need if I want to create this one, I should do 1, then 1 0, then 1 and add a 1 and create it a 1 1. So this one I want to add 1 here. So what I will do, I won't take to the power of 2, but I will multiply by x. So it will be x to the power of 1 times x to the power of 10, all of this in base of 2. So remember that 1 0 base of 2, what will happen here is, yeah, it's x to the power of 1 plus 1 0 in base of 2, right? So what is the result? So this is 1. So it's 1 1 in the base of 2. This is exactly what we wanted. I converted the 0 to 1. So this is what I'm doing here. So what I will get here is just x to the power of 1 1 2. Now what do I want? I want a 0 here, so I will square this. I will take x to the power of 11 base 2 and square this. This is exactly what I did here. Remember that 1 1 in binary is 3. I squared here, so I get x 1 1 0. Now the next thing I want another 0 and then convert it to 1. So I need another exponentiation, so I take x 1 1 0 squared, getting x 1 1 0 0. This is again base of 2. What I'm doing now is 1 1 0 0. Oh, I want to convert the last one here to 1 here, so it's x times x 1 1 0 0. So it's x 1 1 0 1. And now what I want is another 0, so let's again make squaring. So it's x 1 1 0 1. Take the square and getting x 1 1 0 1 0, and this is exactly what I wanted. This is how I knew when to square and when to multiply. What I did is just to create this number using squaring and multiplying, and this is how I knew how to do it. And this, I got a more efficient way to calculate x to the power of 26 instead of just doing x times x times x times x and again 26 times. And this is the fast exponentiation algorithm, and I learned it in cryptography from a video of Christopher Path, lecture 12 of him. Thank you very much. If there are any mistakes or corrections, please tell me. The idea again is to convert the exponentiation to binary and start building a binary, remembering the squaring, moving the number to the left and adding a 0, and multiplying by x, convert 0 to 1. And this is how I know when to square and when to multiply. Thank you very much. If there are any mistakes or corrections, please tell me, and that's it.